Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. In here, we are from Group 7. We will present our topic about insect active sampling technology. But before we start our topic today, let me introduce our group. First is Ananda Fitrianta Susilo, number 113, and then Hanifah Salsabila, number 114, and Aditama Satya Graha, number 124, and Luthfi Nanda Resta, number 132.
First, introduction. Insect active sampling technology. There are two major collecting approaches to sampling insect. Active collecting, such as sweep netting, foliage picking, suction insect device, visual observation, capture-recapture technique, and passive collecting, where traps are set to either attract or intercept insect, including pitfall traps or baited pitfall traps, malaise and flag intercept traps, light traps, and collecting at light seed, sticky trap, pheromone trap, and yellow pants. Different collection methods are used to target different types of insect, such as crawl insect, flying insect, plant inhibiting insect, ground-dwelling insect, and cryptic insect. Active sampling encompasses visual observation, subnetting, and the use of potters and related recipients. It is very important to choose the collecting method and device according to preservational aspect.
Next, we will explain about suction insect device. In taking insect samples, tools are needed, especially for small insects. One of the tools for taking insect sample is an aspirator or insect sucker. Aspirator or suction device is a tool to collect small insect and not very active move like leaf hoppers by sucking them. This tool is used to collect live insect. An example of the tool is defect. Portable suction device. Defect is a portable aspirator activated by a gasoline engine and carried on the back of a person. The advantage of defect vacuum sampling is compared to other sampling technique is the more complete extraction of tiny invertebrate species and immature forms of even large species from the environment. Due, the, due to the pressure built up by conventional nets while sweeping, insect of low body mass simply do not enter them as they are caught in the overflow of air pressure built up as the net is sent through the air. By applying suction to the collecting bag, this inertia of air at the entrance of the net is overcome and tiny forms are collected more readily.
Next is SweepNet. SweepNet samples are most frequently used to obtain estimate of frequency distribution of species, development stage, and sexes, but occasionally are used to estimate relative abundance, species richness, and species diversity. SweepNet samples on short grass and tall grass prairie are typically taken by transversing a sweep net in horizontal way. For other insect groups in other habitats, sweepnet samples are often taken by sweeping in vertical arc. Differences in vegetation structure affected the number of grasshopper captures per sweepnet sample. Sweeps taken in alfalfa capture fewer of the grasshopper present than sweep in grassland. Research found that grasshoppers were captured more effectively on burned areas than on unburned areas. Sampling with a speed net is commonly used to monitor many alfalfa pests when alfalfa plants are at least 6 to 10 inches tall. A 15-inch diameter sweep net is the standard sampling tool used in alfalfa. The way in which this sweep net is used can greatly influence its effectiveness for collecting insects in alfalfa and consequently pesticide application decisions based on the number of insect trapped. Therefore, standard methods have been developed for sampling so the results are standardized. Many slow-moving insects such as pupae larvae, aphids, and caterpillars can be counted by turning the net into a wide pan or even the hood of a shield. Divide totals by 5 to get the average number of insects per sweep. To get a good representation of insect number in the alfalfa field, take sweep net samples in 4 different areas or the field starting from the field margin and working towards the interior of the field. There's a video about how to use a sweep net.
Today I'm going to show you how to sweep alfalfa to monitor for caterpillars, leafhoppers, and weevils. You're going to use a 15-inch diameter net with a canvas bag like this one, and you're going to want to sweep when alfalfa plants are at least 6 inches tall. Swing the net in a 180-degree arc, so the rim should strike the top 6 to 8 inches of alfalfa. You want to hold the net slightly less than vertical, so the bottom edge strikes the alfalfa before the top edge. So sweep in a 180-degree arc from right to left. Take a step, left to right. And you want to do about 5 to 10 sweeps. On your last sweep, quickly pull the bag up through the air, grab it at the midpoint, and then slowly invert it to inspect the pests you've collected. From here you can inspect the bags in the fields in the net. You can use a tray, or if you need to take them back with you, you can put the insects in a plastic baggie. Seal it up.
Next is visual observation. Visual checking has an important support role in some situations, e.g., examining flowers or terminals for eggs or small larvae, checking leaves, particularly lower surface for aphids, mites, and silver leaf whitefly, or digging below the soil surface with a trowel or shovel to assess soil insect activity. Visual observation is a technique that should not be underestimated. Observing insects in their natural habitat yields information on their behavior, commotion, and preferred microhabitats. While such specimens can be collected by hand or with jar or a vial, respectively. In this way, non-flying arthropods from substrates and from under rocks, stones, or bark are usually collected. Recording using only visual observation is only suitable for taxonomic groups that are easily recognized in the field.
Part 5 is a capture-recapture. Capture-recapture technique is a method involving capturing a number of animals, marking them, release them back into the population, and then determining the ratio of marked to unmarked animals in the population. Capture marks recapture is a method of estimating a population size. The method used for mobile animal population. The sample from the population is captured, marked, and released. A second sample is then captured after an interval, and the total number of organisms in the sample and the number within the sample who are marked are recorded. Next. Let's consider an example. Suppose you want to know how many box turtles are in the wood park. On the first day, you hunt through the wood and capture 24 turtle. You place a spot of paint on each turtle shell and release all the turtle back where you found them. And a week later, you return, and with an extraordinary effort, and you can catch 60 turtle. Of there, of this, 15 are marked and 54 are unmarked. Since you know how many turtle you marked, sample, and recapture, you can figure out the size of the whole population by the definition above. We know N is the population estimate, M equal 24 from market individual release, S equal 60 from size of the second sample, R equal 15 from marked animal recapture. And then input in the Lincoln Patterson index. 24 multiplied 16 divided by 15, and the results equal 48. Next.
The last one is conclusion. Different collection methods are used to target different types of insect, such as crawling insect, plant-inhabiting insect, ground-dwelling insect, and cryptic insect. Active sampling encompasses visual observation, strip netting, and the use of potters and related recipients. It is very important to choose the collecting method and device according to preservational aspect. Suction device is a tool to collect small insect and not very active move by sucking them. An example of tool is the fact. SwipNet samples are most frequently used to obtain estimates of the frequency distribution of species, developmental stage, and sex, but occasionally are used to estimate relative abundance, species richness, and species diversity. Visual observation provide information on the presence and absence of pests and beneficial insect. Monitor for damage from pests, since often the pest is long gone, but the damage remains. Capture-recapture technique is a method involves capturing a number of animals, marking them, releasing them back into the population, and then determining the ratio of marked to unmarked animals in the population. Capture-mark-recapture is a method of estimating a population size.
So this is the end of the presentation for us. Thank you for your attention, and wassalamualaikum warahmatullahi wabarakatuh.